In this circuit we need to find the voltage V naught here using node voltage method. So first let us identify this node as the reference node. This whole node is the reference node. So the voltage here is 0, so the voltage at this point will be 10 volts because there is just this voltage source, and this voltage, the voltage of this point, this node is V naught, and this one here we have a current dependent voltage source, and it is the negative side is, this one is negative, so the voltage at that point will be, here the voltage will be 20 minus 20 I naught, I delta, so that will be the voltage there. So let us first write, we need to find V naught. Let us first write the KCL equation for this node, the 10 volts node. So we know the voltage there 10, so let's call this any, maybe what, node 1 or whatever, doesn't matter. So I'm writing the KCL equations for this particular node. So first the entering current, this one, which is I delta. So I'm writing the entering currents in the left hand side, it's alright. And then I will write the other currents as leaving current. So this current will be 10 minus V naught, 10 here minus V naught over 10. So that will be the current, 10 minus V naught over 10. This is one leaving current, the other leaving current in this direction will be 10 minus 20 I delta, so that will be 10 minus minus, so that will be plus 20 I delta over 30. The resistance here is 30, so that's there, I delta here and 30. So I will multiply both sides by 30, so that will become 30 I delta is equal to 10 minus V naught, so that will be 10 minus V naught multiplied by 3 plus just that one, so 10 plus 20 delta, 20 I delta, so that's 30 I delta there, that's 30 minus 3 V naught plus 10 plus 20 I delta. So if I rearrange this one, it becomes 10 I delta plus 3 V naught is equal to 40. So this is equation 1 that I have. Now let's write another KCL equation for this particular node, which is V naught here. So when we write KCL for that node, we have the leaving current, we will write all the currents as leaving currents. So the current through this 40 ohms resistance in that direction will be V naught over 40. So that will be V naught over 40 plus V naught minus 10 over 10. So that is this current, which is V naught over minus 10 over 10. And then finally this current in this direction, V naught minus 20, so that will be plus V naught plus 20 I delta over the resistance here is 20 ohms, so that's 20, so that's is equal to 0. All three currents as leaving currents, since we didn't have any designated current here, that is like I delta was not there. So I now multiply both sides by 40, so it becomes V naught plus the second one will be 4 V naught minus 40 plus this one will be 2 V naught 2 V naught plus 20 I delta is equal to 0. 2 V naught plus 40 I delta, that will be, so it will be 7 V naught plus 40 I delta is equal to 40. So that will be equation 2. So we have two equations and two unknowns. here we have I delta and V naught, here we have I delta and V naught. So what I will do, I will multiply equation 1 by 4 and then 1 times 4 subtract 2. That should work. So that will be 40, 1 times 4 will be 12 V naught plus 40 I delta is equal to, finally on the right hand side will be 160, 40 times 4, and this right equation 2 will not be multiplied by anything, just whatever is there I will write down, because I have 40 I delta now. I don't want I delta to be there, I'm trying to cancel I delta out, so that will be 40 here. So now I will subtract, and when I subtract, these two get cancelled, so it becomes 5 V naught here, and on the right hand side it's 120. So I get V naught 120 over 5, that's 24 volts. That's what I wanted to get.